So we're going to begin a very short unit just talking about sequences and sums of sequences. Now, we're only skimming the surface for this. Sequences and series, you can actually look at the textbook for a lot more information. And actually, the whole concept is very, very important. It can get extremely complicated. However, it is very, very important for a lot of aspects of mathematics. So if you go on to study further mathematics or even calculus, you may get more details about this and may explore this more in depth. For us, we're really taking this as sort of a pattern, as sort of a formula. So here I have this list of numbers, and what if I wanted to guess the next number? What would the next number be? Well, if I examine this, I can see that I'm adding 4 each time. So this is plus 4, plus 4, plus 4, plus 4. So if I have 23 plus 4, I'm going to get 27. And that's easy, right? Just figure out what the pattern is. And chances are in grade school or before, in some other math classes, you may have had worksheets or problems like this, like figure out the pattern and what's next. Now, while this is easy, sometimes on SATs and ACTs you'll see questions like, okay, what's the next term? 27, easy. Okay, what's the 100th term? Ooh. And so now you're just going to have to add 4, 100 times or do a lot more work. And the intention for a question like that is that the test takers, they don't want you to spend your time. Or if they do, it's a trick, it's a trap. There's an easier way, and it's defining it as a sequence. So an arithmetic sequence is something that we add or subtract each number. So here, this is actually an arithmetic sequence because for each value, we are adding 4 to the previous. This addition is called the common difference. And so here's what we have. So right here I have a sequence of numbers. So I'm going to call them all A with different subscripts. This is my first A, second A, third A, and I go all the way to N. N could be any number. I could have 5 values here. I could have 1,000,000, whatever. By putting subscripts, it helps me write all these. For each of these, I'm going to add a certain amount. I'm going to add the common difference. It helps if I can spell difference, but I add the common difference. So that's how much I add to each value before. So for our example, 7 plus 7, 11, 15, 19, 23, I was adding 4 each time. This is actually the general form for the equation. A sub n, so the nth term, is going to be equal to the first term plus n minus 1 times that common difference. So for our example, we were adding 4 to each time, or to each term. So that means that our common difference is 4. So our equation is going to be a sub n is equal to the first value, which is 7, plus n minus 1 times that common difference of 4. Now, we would not leave our equation like this, so we're going to clean it up. So we get 7 plus 4n minus 4. And we combine our like terms, so we get a sub n is equal to 3 plus 4n. And that is our equation. There we go. And we can test this out too. So, for example, when n is equal to 3. So what's the third term? Well, a sub 3, the third term, is going to be equal to 3 plus 4 times 3. So that means that the third term is equal to 15. That's 12 plus 3. And that's actually what I have. That is the third term. So this is a great way. So if I have a pattern of numbers like this, an arithmetic sequence, if I wanted to figure out the 170th number, I don't have to add that common difference all those times. I can just write this common formula and plug in whatever I want to find into n. And we can also work backwards with this as well. So here, I'm given the equation, and I want to find out the sequence. Well, all we have to do is find a sub 1, a sub 2, and the common difference. So we know that the common difference is equal to 5. Why do we know that? Well, because that's the coefficient for n. Right? Look back at this example. What were we adding each time? 4. And that's what the coefficient for n was. So for this, we have 5 as the coefficient for n. Well, what happens if I plug in 1? When n is equal to 1, that's the first term. So when n is equal to 1, I have 5 minus 6, which is negative 1. What about when n is equal to 2? When n is equal to 2, I have 10 minus 6, which is 4. Well, wait a minute. I'm adding 5 each time. That's my common difference. Is there a difference between these of 5? Yeah, there is. Negative 1 plus 5 is 4. 4 plus 5 is 9. And 9 plus 5 is 14. And so on and so forth. So that's it for these. So we can, given a sequence, we can find the equation, or given the equation, we should be able to find the sequence. And that's it. Then there's also sums. So this is only for finite sums, only for arithmetic sequences. Finite sums means it ends. It's, you've seen the word infinite before, never ending. Finite means it does end. So here I have a finite sequence, 5 through 65, counting by 5s. This is the sum. So S sub n, well, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So sum of the 13 digits is going to be equal to 13 divided by 2. 2, 4, 6, 8, 10, 12, 13. Yeah, okay. It's going to be 13 divided by 2 times a sub 1, which is 5, plus the last digit, 65. So this is going to be equal to 13 over 2 times 70 over 1. The 2 and the 70, they should reduce, so we actually get 13 times 35. So 13 times 35. That's going to be 455. So 455. And that's it. Now I know it seems kind of tedious, well, we have to calculate this, so why don't you just add all these up? Well, sometimes they don't give us the full sequence. Or maybe they give us a sequence and they say, all right, the first couple terms are this, and the last couple terms are this, and there are 300 terms. Well, then are you going to add all of them up? No, absolutely not. So this really is a time saver. If we're given a small group of numbers, even these 13, yeah, maybe it's probably going to be just about the same amount of time to add all these up. But if we were given 130 terms, yeah, there's no way I'm going to be adding 130 terms in my calculator. So this is just a great way to stay forward. So sums, finite sums of arithmetic sequences, and then arithmetic sequences. That's it for this section, and that's all that we're going to cover.